Hi friends, today we are discussing a new section of our syllabus, that is magnetism. We already learned magnetism in our small classes. The basics are same, but I have to remind you again. So we will start our section from the basics of magnetism. So according to the history, the northern Greece shepherds of that area discovered some stone. They had the magnetic or attractive property. First they called magnetite or a ghost stone, like that, because a shepherd uh, who had the foot wear with iron plates down. So when he stood on the surface of a rock, he felt attractive force. So he thought that there was a ghost stone, and that is the first writings of the history of magnetism. And that stone's name was Lordstone. That was the natural magnet. Okay. Nowadays, as you know very clearly, we are dealing with the man-made magnets or artificial magnets. Artificial magnets are made by either soft iron or steel. Why this difference? Permanent magnets are made from steel. Temporary magnets are also called electromagnets. Okay, they are made from soft iron. So we will look in detail. These are the different shapes or different types of magnets you saw already in your daily life. And about the poles of the magnet. A bar magnet consists of not only magnet always dipole in nature. There are two poles present always, North Pole and South Pole. And the basic rules already we learned. Like poles always repel. That means north repel, south always repels. Unlike poles attracts. That means when you bring a north and south pole together, they will attract. That you know very clearly. So this is the basic rules of magnetism. Then if you cut the magnet, is become monopole. Monopole means single pole. No. If you cut the magnet again, you will get two magnets with the dipole nature. Okay, you can see in the picture. But the strength of the magnet will decrease. I hope you clear. So there is no magnetic pole, monopole exist. Magnet always dipole in nature. So in order to represent magnetic field, you know what is magnetic field? Surrounded by a magnet, there will be a region. It can influences other magnetic substances. So as you studied electric field. So in order to represent magnetic field, we are drawing a curved line starting from north to south outward and south to north inward along the axis of the bar magnet. I hope you clear. So this is the basic difference between electric field and a magnetic field. We will discuss in detail. Okay. Then this is I already discussed. Like poles repel, unlike poles attracts. Okay. S stands for south and N stands for north. And this is the comparison of electric and a magnetic field. The basic difference is magnet is always dipole in nature. In electric field, both the dipole and monopole are existing. I hope you clear. Then as we already learned the properties of electric field line, like that there are many properties for a magnetic field line. Only the difference, as we studied about electric field, we learned the direction of electric field from positive to negative. But in the case of magnet, the direction outside north to south and inside the magnet it is south to north. That means magnetic field can form loops, closed path. Okay. Electric field is not closed. I hope that is only the difference. Remaining all are almost same. Okay. And the maximum strength of the magnet is at the poles that you already learned. Okay. Then our Earth also possesses magnetism. And what is the reason behind that? Many theories are there, but the existing valid theory, Earth core consists of molten state minerals and ions. As the Earth spin and revolve, these charges are also moving. As we studied, the moving charges produces magnetic field surrounded by it. So many people are believing that is the reason behind earth magnetism. Till now, there were no proof, but this theory having some validity. Okay, so we are imagining Earth as a huge magnet, a giant magnet. So as we know already, if you got a compass needle is a simple bar magnet suspended in a what is called a knife edge. So if you kept a compass needle horizontally, it will always align north-south direction of the earth. Remember, we are telling north-south direction of earth is geographical north-south pole. There is a hidden magnetic north-south pole. Because of that, magnetic needle are aligning in a particular direction. And compass needle is used to what is called know the direction. Okay. So we will discuss about compass needle and earth magnetism detail. But you should know earth having magnetic north and south pole. Earth will consider as a giant magnet. You can see from the picture. Okay. Then this is the natural phenomena. A beautiful creation you can see in the sky. Okay. And that is called aurora borealis and aurora australis. It is because of the magnetic field of earth. Okay, light pattern appearing in the sky from the solar radiation. Solar radiations are trapped in the magnetic poles of the earth, north pole or south pole. So depending upon that, this effect may arise. We will look in detail. Okay, so it's a natural phenomenon that is called aurora borealis and aurora australis. Okay. At North Pole it is Aurora Borealis, and in the South Pole it is Aurora Australis. Okay. Then what is the reason behind? Some material shows magnetism. The remaining material are not able to possess any magnetism. So you just imagine a paddy field. If an elephant approaching to a paddy field, after some time you can see the paddy field is totally distracted, randomly what is called distracted. But you just imagine the paddy field after a wind, one directional wind, all the cultivation will align in a particular direction. Otherwise, you can say our hair. After applying gel or after what is called a bath, we are applying oil. The hair align in a particular direction. Otherwise, different hairs strands are different direction. So you can see three pictures down. An unmagnetized iron, their direction, magnetic directions of individual dipole or molecules are different. Okay, they will cancel. But if you keep that material, iron material, an external magnetic field, the presence of external magnetic field makes the alignment in a particular direction. Okay, so that become magnet. That's why if you are rubbing or rubbing a magnet on an iron bar or a nail, after sometimes it can show some magnetic effect. This is the reason. If you drop the magnetic effect will reduce. This is the reason. Perfect alignment of molecules in a material makes the magnetism. So if you drop that, alignment will change, so magnetism will decrease. Okay. It is called domain, that direction and all those things. That I don't want to explain more. We will discuss in detail, no problem. A non-magnetic material having no direction and all those things. Okay. So this is the basic reason about magnetism. And this is one of the best application of magnetism nowadays we are using. Unfortunately, they don't have any till now. It is called a maglev. Okay. High speed transportation system needs special track. Magnetic levitation, from there that term arised maglev. Levitation means suspending in air. Okay. So with respect to applied magnetic field, both the rail and the bottom part of the train are magnetic material. There is no need for any motors. With respect to change in magnetic field, it will work. Okay. High speed bullet train. We will discuss in detail. Now it's an introduction section. Then we are using many applications. Our all the memory, including pen drive, hard disk, memory card, CD, all are magnetic memories. Okay. Then in the what is called big applications, huge applications like a roller coaster, the big one, and the fridge door, computers, and the microwave oven. Then what is called medical uses are there. Magnetism keeping inside the stomach of cow. So while eating or from the grass, or if any magnetic iron fillings is what is called reaching the stomach, it can attract and keep somewhere. So it will not hurt anywhere. So plenty of applications we are discussing. This is only an introduction section. Then another application, a huge magnet can what is called rise big, huge metallic what is called pieces. And this is, you can see, a scrapyard. After crushing or grinding, we can select the magnetic material by using a huge magnet. This is using our container terminals to take the containers from ship to other transportation facility or vice versa. So everywhere we are using magnetism. Okay. I hope you clear. This is only an introduction section. We will discuss in detail.